So, picture this, it's right at the end of World War II. Scientists at Los Alamos are working with a small, heavy sphere of plutonium. It's just about 6.2 kilograms, barely 3.5 inches across. But by the time they were done with it, this little object would earn a much, much more sinister name. This is a story of how it got that name.
This quote, it really sets the stage, doesn't it? It sounds like something straight out of a classic horror movie. And honestly, it perfectly captures the story we're about to get into. It's a story of brilliant people pushing the absolute limits of physics and the terrifying consequences when those limits pushed back.
So that's the big question, right? How does a simple-looking sphere of plutonium get a nickname like the Demon Core? Well, this wasn't just any piece of metal. It was the heart of what was supposed to be a third atomic bomb. But two catastrophic accidents gave it a whole different legacy. And to really understand how, we first have to talk about the science they were exploring.
You know, the experiments these scientists were running with the core, they had a nickname. A nickname that really tells you everything you need to know about how daring and how dangerous this work was. They called it tickling the dragon's tail. And that dragon was a full-blown nuclear chain reaction.
Okay, so the key idea here is something called criticality. The easiest way to think about it is that it's the ultimate tipping point for a nuclear reaction. The scientist's whole job was to find the exact edge of that point. If you stay just under it, the reaction just kind of fizzles out. But if you go even a tiny bit over, you get an uncontrolled, explosive release of energy.
And this right here shows you the razor's edge they were walking. On one side, you have a subcritical state. That's the safe zone, where the chain reaction dies out. On the other side is supercritical. That's what you want in a bomb, where the reaction just cascades instantly. The entire goal of these experiments was to get as close to that line as humanly possible without ever crossing.
And the way they did this is, well, it's kind of shocking today. It was completely hands-on. They would surround this plutonium sphere with other materials, things like tungsten carbide or beryllium. These materials act like mirrors, but for neutrons. They bounce any stray neutrons back into the core, nudging it closer and closer to that critical state. And that brings us to this legendary quote from the physicist Richard Feynman. He's the one who called it tickling the tail of a sleeping dragon. It's just the perfect analogy, right? You might learn something by poking it, but if you poke it just a little too hard, or if your hand slips, that dragon is going to wake up. And that is exactly what happened.
Twice in less than a single year, the dragon woke up. And both times, the very first sign of the disaster was this silent, absolutely eerie flash of blue light. The first victim was physicist Harry Daghlian, just a few weeks after the bombing of Nagasaki. And then, only 9 months later, his colleague Louis Slotin met the exact same fate in an almost identical experiment. Daghlian's accident was just a moment of simple, tragic human error. He was working alone late one night, stacking these heavy, neutron-reflecting bricks around the core. As he was moving the very last brick into position, his instruments started screaming at him. The core was about to go critical. He quickly pulled his hand back, but in doing so, he dropped the brick right onto the assembly.
9 months later, Louis Slotin was actually demonstrating this same dangerous procedure to several other scientists. He was lowering the top half of a beryllium reflector down over the core, but he was using only a flathead screwdriver to keep a tiny gap open, and then it slipped. The gap closed, and in an instant, the core was fully enclosed by the reflector.
In both cases, the result was immediate and terrifying. The moment that reflector fell into place, the core went supercritical. An intense wave of radiation shot through the room, ionizing the air around it and creating this ghostly blue flash, a phenomenon we now know as Cherenkov radiation.
And in that split second, before anyone could even process what had happened, both men had absorbed a fatal dose of radiation. Daghlian died 25 days later. Slotin, in an incredible act of heroism, actually knocked the reflector off with his bare hands, almost certainly saving the other men in the room. But he had sealed his own fate. He died just 9 days later.
Now, the stories of Harry Daghlian and Louis Slotin are famous, really seared into the history of the atomic age. They're the reason we call it the Demon Core. But their stories, as tragic as they are, can sometimes obscure a wider, lesser-known truth about the real human cost of building the bomb.
2. That's the number everyone remembers. 2 brilliant scientists, killed by the bizarre, new physics that they themselves were pioneering.
But were they really the only ones? While their deaths were absolutely unique and horrifying, focusing only on them gives us a pretty skewed picture of the real dangers that the thousands of people working on the Manhattan Project faced every single day.
See, when you look at the actual records from Los Alamos during that time, a totally different story starts to emerge. While 2 men died from these criticality accidents, at least a dozen others died from far more ordinary causes. We're talking about construction workers killed in explosions, people killed in car accidents on those dangerous mountain roads, even a janitor who accidentally drank antifreeze. Their deaths were just as tragic, but they'd become the forgotten fatalities of the project.
The story of the Demon Core doesn't just end in tragedy, though. Its legacy is a fundamental, massive shift in how we approach nuclear science. These awful events became the catalyst for some really important changes.
And the change was dramatic. After Louis Slotin died, Los Alamos immediately put an end to all hands-on criticality experiments. The era of tickling the dragon's tail with a screwdriver was officially over. It was replaced by remotely operated machines, controlled by scientists from a safe distance, usually behind several feet of concrete. The Demon Core accidents are the direct reason for the safety protocols that are completely standard in the nuclear industry today.
At the end of the day, though, behind all the science and the safety protocols, this is a human story. This quote here is from Louis Slotin's father. He was explaining why he flew to his son's bedside. It just reminds you of the profound personal loss. It wasn't just some scientist who died. It was a son, and he was respected and loved.
So let's just quickly recap what we've talked about. The Demon Core got its name from 2 fatal accidents back in 45 and 46. These events showed everyone just how incredibly dangerous hands-on nuclear work could be. But we also saw that the project's true human cost was much broader than just these 2 famous incidents. And maybe most importantly, these tragedies are what led directly to the modern safety rules that protect scientists today.
And that really leaves us with a question that feels just as relevant today as it did back in 1946. The story of the Demon Core forces us all to ask, when we're pushing the absolute limits of what's possible, how do we decide what an acceptable risk is? And that's a question without any easy answers.